The students hello winja don't you winja that you mar phone donge apenjo giga can you hear me hiyo whatever
hiyo stand tumie tu hivyo ili kupea hata nafasi ya kukua class. So unafaa kutafuta yenye watu wanaikanga hapa hii ya bluetooth. Kuna wengine wanaangu tu kwa nguo, wanaangu tu kwa mahali hata kwa nguo. Hivyo
wanakuwa. Good evening, students. Welcome, welcome, welcome. BMLS upgrading. We are having our revisions today for carbohydrates. Welcome, good. We are at 10. We log in. We welcome all, even BCHB. If you'd like to know something about the carbohydrate structures, we are going to learn. I sent revision questions. Welcome all. Let's log in. Let's log in. Welcome, welcome, students. Welcome our session. Oh yes, Francis Mwangi, welcome. MBCHB, welcome. Welcome all, my dear. Let's learn much about the structures of the carbohydrates. We are here to learn. Welcome. I welcome you all. BMLS upgrading MBCHB. We can stay on board, and a few of my students, BPH. Anyone can join. Hello, Mike Courier. Just tell me MBCHB or BMLS upgrading. I say thank you for subscriptions, for sharing, for likes. Let's keep on subscribing, sharing. As we log in, we need to learn a bit of structures, carbohydrates. We are going to have a revision on carbohydrates based on whatever we've learned so far. Carlos, yes, welcome. Mike or MBCHB, welcome. Welcome all. I'm looking for upgrading. Anyone? BMLS upgrading OV or Beatrice. Welcome, welcome, welcome all. Let's take 10 minutes in welcoming the students. We can start by 9:25. What about carbohydrates? Hello, MBCHB. Hello, Benedict. Welcome, welcome, welcome. I sent the revision questions. So we are going to follow those questions, and we are going to learn on how to draw the structures. For my BMLS upgrading, we've already covered carbohydrates, and I mentioned, hello, Shwala Henry Chanel. Welcome. Hello, hello. We welcome you all. So for BMLS upgrading, I'm already done with carbohydrates, and I promise that before I start a new topic, that is proteins, amino acids, good. Oh, class rep, fellow is there. Bernard Movie, welcome. So I promise that we have to revise so that we can catch up with the structures, the ones which are not clear. We are going to draw. You can see at the back, I have a board. In my small house, I have a board. So we are going to draw the structures. We are going to revise. Graphene Okyoga, welcome, welcome. Welcome all. We are going to invite students until 9:25. So let's keep on logging in. If we have the MBCHB together with BMLS app, and then I'll start by 9:25. So that we don't take much time, since tomorrow is a holiday and you had a hectic day. So I need not to take much of your time, but we'll just take maybe 1 hour to learn much about the structures, what we need to know about the structures. But then we are going to follow the sample questions which I sent. I'm still welcoming everyone. Odero Millicent, yes, welcome. Upgrading, I welcome you all. Welcome. Keep on logging in. I thank you so much for the subscriptions. You are wonderful people. My students, you are wonderful people. We are already at 1,232 subscribers. I don't take it for granted. I say thank you. And together we shall make it work. Musioki, upgrading, welcome. Onyancha Simply, welcome MBCHB. I welcome you all. Let's keep on logging in. I'm still welcoming the ones who are still not there. And the ones who are still wondering where we are logging in, you can just share the channel link so that we can start together. But just tell me in the chat. I'll be able to see. BMLS app, Mwasia, Caroline, welcome. Welcome all. Let's keep on logging in. Let's keep on logging in. As I open my questions, let's log in. Or I think the 10 minutes is too much. You can see what you suggest. Phoebe Oruko, welcome. Patra, welcome. Fellow, you can tell us. Maybe I can start by 9:20 because I said 9:25. It will be a little bit later. So we can proceed. We'll proceed by 9:20. We'll start so that the other students can get us as we move on. So Fellow already told me, yeah, Nema Kanene, welcome MBCHB. Fellow already told me they got the sample questions. The MBCHB didn't tell me, but I'm sure they got them for the ones who want to join. So it wasn't by force. They can just join so that they know, because we need to move together. In any day you do the cuts, then you'll be able to know what you need to draw or what you need to answer in any case it is been asked. As much as I'm not teaching MBCHB this time molecules, but still structures are the same. So the way you are being taught by Dr. Kate, it is still the same as how I'll be teaching it. So it will be of help at a certain point, then that will be fine, or that will be great. Fellow, can you tell me if I start? Douglas Juma tells me we are in. Welcome, my dear. Zaid Hassan, MBCHB, yes, he's telling me they got it. Thank you so much. 9:20, good. Fellow has answered. And Fellow, your watch says I'll give 1 minute, because I can check my clock is already at 9:20, because we need to start. They'll get us as we proceed. We don't need to take much time. People already had a hectic day, as much as tomorrow is a holiday, but we need to. I always like 1 hour and then I leave. I don't like to take much time. So we're already starting question number 1. Let them join, but then keep on subscribing, liking, comments. If anything is not clear, just do the chat. I'll be able to see and I'll explain. Please don't keep quiet when you don't understand. Yeah, Fellow says okay. So we are off to the first question. I'll be able to read from my laptop as I draw or as I explain. So I told you the secret is we need to know the structures, be it the carbohydrates, be it the lipids, be it the proteins. We need to know the structures, and the structures will come from the building blocks. So we have to know of these terms. I talked about point number 1 of Roman 1. I said that define the following and draw structures to support your definitions. So if I talk about stereoisomers, you could remember well what we did in class, but it will also help the MBCHB group, because I know you are going to define these terms. when the right time comes for the carbohydrates, as much as you are still doing proteins, but you are going to do these terms. Now, I said for the stereoisomers, they have the same molecular formula and they're of the same functional groups. So mostly whatever we were defining much in stereoisomerism, we looked at the 6 carbon sugars. So those are the monosaccharides which are known as exoses. And then we said they're of the same molecular formula. And we said that the formula for carbohydrates is CH2O bracket N. It means at the point now where we have the exoses, the N will be substituted by 6, and you'll talk about C6H12O6. So in this case, we're talking about stereoisomers. They're of the same molecular formula, which you can see if they're exoses, it will be that. If it's trioses, you'll substitute N by 3. If it's tetroses, you'll substitute by 4. If it is pentoses, you'll substitute by 5. So they're of the same molecular formula, but they differ in structure, meaning they are mirror images of one another. And we gave the best example here is if you look at D-glucose and L-glucose, those are stereoisomers. They're of the same molecular formula, of course, they are exoses. So if you talk about glucose, for example, 1, 2, 3, 4, 5, 6, we said, when you are drawing the monosaccharides, you have to bear in mind the number of carbon atoms and the functional group. So the functional group will be aldehyde group at carbon atom number 1. I don't know whether it is clear. I think my board should be very clear for the students to see. So you have 1, 2, 3, 4, 5, 6. We are drawing stereoisomers. So we start with D-glucose, and we said, since glucose is 6 carbon atoms, draw 6 carbons down the line. 1, 2, 3, 4, 5, 6. Then the first carbon atom has to be an aldehyde group. Other books will draw it as CHO, still the same thing. So the writings are not visible. I need to push the camera a bit. So if you communicate, I'll be able to see your communication. Is it visible now? The blackboard is blurry. Is it my camera? Just a minute. Just a minute. Is it still blurry or the type of, let me see if I can do the other type. Sorry. Is it still blurry? There is a reflection, I think, of the ring light. It also shows the opposite. Oh, the writings are inverted. Okay. Just wait. If you communicate, I'll be able to see. Upside down. Somebody says upside down. Somebody says Harry. Somebody says. Okay. I've just turned it the other way to see if you can see, but I'm trying to do away with the blurriness because it's good if you are seeing than not seeing. Writings are appearing as mirror image. Okay, I've turned it the other way, so I want you to tell me what you are seeing. Writings appearing as a mirror image. It is going to work. Even the other time, we had challenges with the other group, but it worked at last. I'm trying to put it. Just a minute. Let me see. It has to be at the back. We can proceed. I want you to tell me what you can see. I'm trying to adjust it, but now I don't know how I can make it better. There is a reflection there which should not be. Douglas, you're saying we can proceed, but I want people to at least see if I'm writing. Douglas, what can you see? Can you adjust the light again? Yeah, Douglas, can you see something? Still blurry. Wainaina Million says still blurry. Worse than before. Millicent, you are saying, Madam, there is nothing you've done. Worse than before. Okay, let me try the one which was before, and then we can proceed. If we can see something, but me, I can see something. Or my eyes are different. It's not visible, still blurry. No, just give me a second, please. I have to fix it. It will be fixed. That one is visible. Can you see? But somebody is saying it's mirror image. Hapo. Kisa says hapo. Can you leave it? Yes, Kisa says hapo. I'm seeing Kisa twice. So I'll proceed. I want someone good. Uni says correct. Just leave it at that. Thank you. Another person? Oh, wow. Even me, I can see now it's better. Hapo. Still mirror image. The mirror image is what I don't know how we can. I'm only Winnie. What is this Alan Kiprotich saying? Not real mirror image on my side. Okay. No, we are going to cope, please. Just give the comment so that it can help me improve. Next time will be better. Yes, but now the blurriness we have minimized. So as I was saying that we were to draw the stereoisomers. I'm sorry about that. And I said for the stereoisomers, they are the same molecular formula. She's using selfie camera. I'm only seeing Winnie. Oh. The front camera will sort the mirror image issue. So, Douglas, what do we do? Because I don't want to interfere. Should I put it the other way, but now, no selfie? Ah, Douglas, do I? Oh, you are saying? Okay, let me try what you mean. I know what you mean. I think the other group helped me last time. It will work. Don't worry. Yeah, let us just be patient. As long as I'm trying to minimize the blurriness, so I'll do the flip. Is it flipping? Somebody told me last time, Madam, flip. So I'm trying to flip, but then, oh no. Do you know that I'm not Gen Z? I'm a bit old, but now, well, I'm trying to remember what I did last time. When I removed the selfie, what was it? When I removed the weka vizuri. Aya. I'm already live. I'm back. If they can see the board. I'm back. I want you to tell me if you can see. Your reflection natoka wapi? Are you there, my dear people? The board. Good. I'm happy. I'm happy. Good. Yes, very good. I'm very grateful for your patience. Now we are going to proceed. I'm happy that it's better. I'm happy that it's better. Tell the other ones, they just come back. You know, everything needs patience, huh? Because it's good if you are moving together than assuming that some people can see, some can't see, and we just move and other people are lost. Yes. So we are going to write comfortably. So what I was saying, we can see that good. It's okay now. I'm happy. Now, what I was saying was we have to write the stereoisomers. You have to define and draw the structures. I'm looking at my questions. And as I said, now we can move without any difficulty. So I said that, for example, which we had, because we talked about stereoisomers, they're of the same molecular formula, but they differ in structure because they are mirror images of one another. So you will find that we gave an example of D-glucose and L-glucose. So for D-glucose, whatever we said was 6 carbon atoms. Start 1, 2, 3, 4, 5, 6. The first carbon atom will have the aldehyde group. You can draw it like this or CHO, still aldehyde group. The last carbon, which is carbon atom number 6, will be CH2OH. So we said when you are drawing D, count from carbon atom number 1. This is 1, 2, 3, 4, 5, and then the 6th one. At carbon atom number 3, for D-glucose, put the OH to the left. But oxygen should be closer to carbon than hydrogen. It means we are looking at the characteristic of water, ideal biological solvent. When you have OH one side, the H will be the other side. It means carbon atom number 2, number 4, and number 5. The OH is to the right. Still, characteristic of water. As ideal biological solvent, you will have the hydrogens now coming to the left-hand side. Meaning, for us to draw L-glucose, I hope it's visible. My board can be too small, but now we will improve. Someday we will just buy a very big camera. We will be comfortable. God will bless, don't worry. 1, 2, 3, 4, 5, 6. Still the same one. The last one is CH2OH. The first one is aldehyde group. But now, for L-glucose, remember, it's a mirror image of D. So at carbon atom number 3, now put your OH to the right. Then bring hydrogen to the left. It means carbon atom number 2, number 4, and number 5. The OH is now to the left, and then you bring the hydrogen to the right. So you have D-glucose and L-glucose. You've defined stereoisomers, the same molecular formula. They are still exoses. So the molecular formula will come to C6, H12, O6, because we said the general formula for the carbohydrates is CH2O bracket N, where N we talk about 3 and more, because we'll be talking about trioses, the tetroses, the pentoses, the hexoses, the heptoses. So you just substitute N by the number of carbon atoms in the main skeleton. So in this case, you can also draw D-galactose and L-galactose. You can draw D-mannose and L-mannose, as long as they are of the same molecular formula. But if you look at the structure, they are mirror image of one another. That is stereoisomers. So I'm going to rub as we proceed, because these are going to be recorded. So it's okay. By the time you are revising, you'll be able to see in the videos which have been recorded, so that I can have a space again for another question. Roman 2, define functional isomers and draw. We said that the functional isomers, they're of the same molecular formula, but they differ in structure based on different functional groups. Same molecular formula. Meaning, if they are exoses, also functional isomers exist. If we talk about the pentoses, functional isomers exist. You talk about trioses, functional isomers exist. Even for the tetroses, functional isomers exist. So they are of the same molecular formula, but they differ in structure based on the different functional groups. So we are talking much about an aldose and a ketose. So we are going to give the best example here. You give the D-glucose and D-fructose. we are going to draw the structures. Again, you are drawing D-glucose. I said 6 carbons. Put it down the line. 6 of them. 1, 2, 3, 4, 5, 6. Now, we can put CHO. I told you that is also an aldehyde group. That is how you can draw if you can't balance the bonds around the carbon. But now, at carbon atom number 2, put that one. Number 3, put it to the left. Hydrogen will come to the right there. Then number 4 and 5, OH is to the right, bring to the left. The last one is CH2OH. I said, you have to balance the bonds around the carbon. At the time of proteins, or when we'll be able to draw the amines of the sugars, balancing the bonds around the nitrogen. So in this case, if you look at the molecular formula, it is C6H12O6. But remember, we are balancing the bonds around the carbon because atomic number for carbon is 6. So the configuration goes to 2 to 4. It means the outer shell needs 4 electrons for stability. So you have to balance the bonds around the carbon, which has been balanced already. So we have to draw fructose as well. It is an exose. They are of the same molecular formula. They are both C6H12O6. 1, 2, 3, 4, 5, and then the 6th one will still remain CH2OH. But now, remember, at carbon atom number 1 for fructose is still CH2OH. The keto group, functional group for fructose, it is a ketose. The keto group will come to carbon atom number 2. Then you are drawing D, fructose. At carbon atom number 3, put the OH to the left. Hydrogen will come to the right. Still, characteristic of water as ideal biological solvent. 4 and 5, OH to the right. Those are functional isomers. They are of the same molecular formula, C6H12O6, but they differ in structure based on different functional group. This one is a ketose. This one is an aldose. So they are functional isomers. Functional talks about the functional group is different. I'm saying that Roman 3, epimers. You define and draw. In my exam, you are going to draw structures, like 90% drawing structures, just drawing structures. I'm trying to look at many things which the students can understand. Do you understand the functional group? Can you draw how many carbons? Can you place the hydrogens well and the hydroxyls? And when it comes to cyclic form, can you project the cyclic form from the linear form? That's how easy and important it is. So we are talking about epimers. Epimers, they are still of the same functional group. If they are aldoses, they are aldoses. If they are ketoses, they are ketoses. But there is a difference at a specific carbon atom for the epimers, which is not the carbonyl carbon. Carbonyl carbon is a carbon which carries a functional group. So they are of the same molecular formula. They are of the same functional group. But there is a change at a specific carbon atom, which is not the carbonyl carbon, which is not the carbon carrying the functional group. So in this case, we are going to put glucose at the center. It is the reference point. Put galactose, D for that matter, at the left-hand side. Put D-mannose at the right-hand side. We are defining epimers and we are drawing. Remember, I said that 1 mark, 1 mark. They'll see. So, I hope we can see. I'll see the comments as we proceed. 1, 2, 3, 4, 5, and then the 6th one. This is also 6. 1, 2, 3, 4, 5, and then the sixth one. 1, 2, 3, 4, 5, and then the sixth one. They are all hexoses. Let me check if the students are proceeding. Yeah. Can we see? It's a bit faint, but I think we'll be able to see. Let me check another one if I can get there. Yes. There is a black one I have. It has to be clear. So we are saying that let's start with glucose. We've said they are of the same functional group. They are of the same molecular formula. So let me do 1, 2, 3, 4. They have to be 4 bonds around the glucose. Aldehyde group. They have to be of the same functional group. They are also having the CH2OH at the 6th carbon atom. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. You can see they are all aldoses. They are all hexoses. So they are of the same functional group. But there is a change at a specific carbon atom, but not this carbon carrying the functional group. So that's how we define the epimers. So we are going to see how they are epimers of one another. Let me try to draw first our glucose, D for that matter. So if it is D, it is D. If it is L, it is L. That is our D glucose. Then we are going to draw galactose. Remember, galactose, both carbon atom number 3 and number 4 have the OH to the left. Both carbon atom number 3 and number 4 to the left. Let me do OH in blue so that we can highlight the changes which are seen there. Now, mannose is different. At carbon atom number 2 and number 3 to the left-hand side, that is D mannose. That is D mannose. Look at that. It means that if we are talking about epimers, D-glucose is the reference point, such that you say galactose is an epimer of glucose at carbon atom number 4. Mannose, an epimer of glucose at carbon atom number 2. It means when you are talking about epimer pair, glucose has to be present. So you talk about galactose and glucose or mannose and glucose. So we said epimers are of the same functional group, but there is a change at a specific carbon atom, which is not the carbon carrying the functional group, the carbonyl carbon. So this is what we need to draw. You define first, of course, when you give such a question, it will be like 4 marks, because each one of these will be a mark if it appears in the short answered. But in this case, I wanted you to define and then you can draw. So I might talk about 1 mark each, but then this one deserves more than that. But the most important point, can you define epimers? Can you define functional isomers? Can you define stereoisomers and support using a structure? That is how important it is. So you have to talk about the epimers. Glucose has to be there because you can see on all these at carbon atom number 3, they are the same for all the 3 monosaccharides. The difference will only come on galactose and glucose at carbon atom number 4, on mannose and glucose at carbon atom number 2. So it means they are epimers of glucose at those carbon atoms. The other question, I'm checking my laptop for the question before I can proceed. it says pyranose, furanose, hemiacetal, hemiketal. So we are going to draw a structure which is going to answer the 4 questions. I'm looking for my rubber. So this one will be recorded. At last, it will be on the channel. You can revise anytime. So that's why I'm rubbing, so that we can have a space again. I have to check for the questions. If somebody has a question, then I'll be able to. Good. Your camera keeps moving. It's faint. Keyboard. I can clearly see it. Can't you see? Oh, the marker pen. Okay, let me try the good one. So we are going to describe pyranose, furanose, hemiacetal, hemiketal. We said for you to talk about furanose and pyranoses, you have to know how to twist the linear form of our monosaccharides in clockwise direction to form the cyclic or the Haworth projection. And reason being, we said in cyclic form, those disaccharides exist in cyclic form. So the monosaccharide component has to be drawn in cyclic form because the cyclic form increases the solubility of the disaccharides. So we are going to start on the cyclic form. If you talk about the furanoses and the pyranoses, we have to draw our linear into cyclic form, the Fisher's to Haworth projection. So we said, whatever we discussed in class was aldoses. Whatever I've just drawn for galactose, for glucose, for mannose, they are going to form a 6-membered ring known as pyranose, meaning fructose having a keto group at carbon atom number 2, and the other 5 carbon sugars or the pentoses will form a 5-membered ring known as furanose. So from my glucose, I have to do the glucose as the best example here. From my glucose, you know, the body is also dancing a little bit. I'm trying to make it a bit clear. We are going to move. We'll improve as we go. Don't worry, it shall be well. If you talk about the linear form, already it's an hexose. It has the aldehyde group at carbon atom number 1. What happens when you twist it in clockwise direction for it to form a cyclic? Then it means, you see that group? The OH at carbon atom number 5 is going to form a covalent bond with the carbon carrying the functional group. And for the aldoses, that is a point where the hemiacetal is going to form. So I told you people when you are doing the lectures in class that if you see the hexoses, go straight and draw a 6-membered ring. This is what is known as the hemiacetal. Hemiacetal. The covalent bond is forming. The OH at the 5th carbon atom and the carbon atom number 1, which has the aldehyde group, we will have a covalent bond, the hemiacetal. So don't draw something like this. Don't make it a corner, which we can't see anything happening there. No, it's not like this. There has to be the hemiacetal. It means whatever I want here is this. But then to be precise, give me how it looks like. Let us say that we wanted to draw a beta D glucose, a beta. a beta. We said at carbon atom number 1, it determines the beta or the alpha form of those simple sugars. So we said when the OH is above, that is a beta. Now you are twisting it in clockwise direction, whatever you have here. If you twist this one in clockwise direction, it means at carbon atom number 2, the OH will be outside the ring. At carbon atom number 3, the OH will be inside the ring. At carbon atom number 4, the same position as the one at carbon atom number 2, but then this hydrogen here at carbon atom number 5 will sit here, then CH2OH. That is a pyranose. Mannose, galactose, glucose will form. If possible, kindly draw alpha L galactose. Oh, fellow, I'm back. Yes, I'm going to draw. I need the concentration from the students, then I can draw. Bobik says, yes, I'm back. Yes, Bobik wants me to draw alpha L galactose. Bobik, let me start by drawing L galactose. Then we'll see how it results into the alpha L galactose. Very good. So, Bobik, from whatever I have here, I'm not going to change much, but from whatever I have here, galactose is having the aldehyde group at carbon atom number 1. So whatever I've drawn on the board remains the same. But now you said L-galactose. It means at carbon atom number 3 and number 4, the OH will now be to the right. It means hydrogen will be here. Then at carbon atom number 5, at carbon atom number 5, at carbon atom number 2, you get. So still, the hemiacetal is going to form. Nothing changes. The hydrogen will still remain there. But you said alpha. OH will be below at carbon atom number 1. Then you said L at carbon atom number 2, at carbon atom number 3, that is L, and then that is L, galactose, that is L. Carbon atom number 2 now, if it was to the right, it will now go to the left. Remember, you are shifting. Carbon atom number 3 and number 4, for the D-glucose, it was to the left. Now they are both to the right. So they will come outside the ring and the same direction at carbon atom number 3. But now alpha, the OH will be below the ring. Can we also call it a beta D-glucopyranose? Correct. Those names are just long, but the gluco stands for the glucose. The pyranose stands for the pyran ring, you know? Just like you can also talk about galactopyranose. But then the main idea here is we know it will result into a 6-membered ring. Those are the aldoses. At that point, you have to know that on cyclic form, we are talking about the beta and the alpha. On linear form, we are talking about the L and D. So we should know the difference. When you see somebody telling you to draw the beta, and alpha D or alpha L or beta L, you have to draw the cyclic form. When somebody talks about DL without the alphas and beta, draw the linear form. So we've answered, in fact, we've answered question 1, Roman. We've answered question 1, Roman. Oh. So this person already asked for alpha L, which I asked here. So I've already answered the question 2, Roman 3. But then I've answered all in question 1. So we can look at question 2, which talks about D-galactose. D-galactose. I can draw D-galactose so that the ones who didn't get right will get right. L-mannose. I'll draw it on the board. So it means that the D's and the L's are linear forms. So we are going to draw so that we get it correctly. We get it correctly. So the D and the L's, those are the linear forms. Let me look at it again. D-galactose and L-mannose. So when you are drawing, these are linear forms. Please just draw the 6 first. 1, 2, 3, 4, 5. The sixth one will remain CH2OH. Now we know this is the same as an aldehyde group, but we are talking about D-galactose. Go to carbon atom number 3 and number 4. Put the OH to the left, then bring the hydrogens to the right at carbon atom number 2 and number 5. Put the OH to the right and then hydrogen the other side. That is simple. How simple it is. Don't cram. I told you, you will see fire without smoke. Don't cram anything. Try to understand how the structure comes about, and we will make biochemistry very simple to understand. So I'm going to draw L-mannose. L-mannose. Remember, we defined them as stereoisomers, D-galactose and L-galactose. D-mannose and L-mannose. So if you know how to draw D, even L becomes easy. Mannose, still 6 carbons down the line. 1, 2, 3, 4, 5, 6. The sixth one is CH2OH. Sorry. The first one has the aldehyde group. But now, carbon atom number 2 and number 3. Are we drawing L? Okay. L, it will come this side. That is for D. L-mannose. It will come the opposite direction. It means number 4 and number 5 will be to the left. And that is L-mannose. L and D, they have to be in linear form. Then I've drawn alpha L galactose. I'm going to draw beta L fructose. Beta L fructose. Remember, we have to start by drawing L fructose. We said fructose is a 6 carbon, 3, 4, 5, and then the 6th one. But fructose has a keto group at carbon atom number 2. The first carbon is CH2OH. L fructose. For L fructose, at carbon atom number 3 now, take the OH to the right. Then number 4 and number 5 will come to the left. That is L fructose. But now, remember, the second group has the keto group, and then still OH at carbon atom number 5. They are going to make or result into a furanose. 5-membered ring, sorry. So fructose and the other pentoses, the ribose, the ribulose, are going to form that 5-membered ring. But I told you to draw beta L fructose. Beta, the OH is above. Then you will have a CH2OH. You say 1, 2, 3. At carbon atom number 3, look at this. It was to the right, so it will be outside the ring. Carbon atom number 4 will be inside the ring. This is the hydrogen. This is the hemiketal we are talking about. That is hemiketal. We didn't draw it, but then now we are tackling furanose and hemiketal. This is the hydrogen, this one. And then carbon atom number 6 will sit here. 1, 2, 3, 4, 5, 6. That is beta L fructose. Simple as that. And I'll give you your marks. Is there a simple way of mastering at which carbon is the OH to the left or right in each type of sugar? Of course, there is a way of mastering, Abel. If you are drawing D, you've seen a pattern that the referencing point of fructose and glucose, glucose and fructose, it's like they are the opening, the key to understanding these monosaccharides. So for D, what you've seen for glucose, look at carbon atom number 3. For D, when you are drawing D form of that glucose, go to carbon atom number 3, put the OH to the left. Then if you put the OH to the left, put the hydrogen to the right. It means carbon atom number 2, number 4, and number 5. The OH will be to the right, and then put hydrogen the other side. Same with fructose. You are drawing D fructose. Go to carbon atom number 3. Put the OH to the left, and then hydrogen to the right. Then carbon atom number 4 and number 5 for fructose. Now put the OH to the right. So what is directing you for glucose and fructose is carbon atom number 3. Abel, did I try to answer? I want to answer Mwaura. Show how to know the carbon 1 to 6 in the cyclic structure. The one for fructose, which is on the board, let me number. Then Mwaura can see. I know I'm going to draw another cyclic form. Just remind me, I'm going to show you the one for glucose when I'm drawing the disaccharides. So this is, and I should do the blue one. Mwaura, I'm going to number. This is number 1. This is number 2. This is number 3. This is number 4. Number 5 sits here. This corner you're seeing here. Number 6. Mwaura, did you see that one? 1, 2, 3, 4, 5, 6 is up there. Yes? So we are going to learn the numbering by looking good. Thank you. We are going to look at the one for glucose. Just remind me, I might have forgotten. And I'm going to number, and I'll tell you. Oh, Eunice. Which one should I repeat? The one for Mwaura or the one for Abel? Eunice, which one should I repeat? Just type, I'll see your response, what you want me to repeat. Eunice, I'm waiting so that I can go to the next question, next structure. Eunice, what should I repeat? The one, good. The one for Mwaura was asking show how to know the carbon atom number 1 to 6 in a cyclic structure. And since I have it on the board for furanoses, I've just labeled carbon atom number 1. Eunice, you can see on the board. Maura wanted to know how the numbers of the carbon come about. Number 1 is the one with the CH2OH. If you draw the linear structure to the left, you can see. So then number 2, you can see there. Number 3, number 4, number 5, and then the 6th one is up there. Why is fructose having 6 carbons? Oh no. Odero, you can't have 6 carbons and pentose on one line. Merely, one line cannot have pentose and the same line has 6 sugars, 6 carbon. 6 carbon, you are confusing these two things, huh? We are talking about a 5-membered ring. If you look at the number of carbon atoms, the main skeleton, fructose, glucose, mannose, galactose are hexoses. But at the time when you are forming the cyclic figure, the cyclic structure, now being fructose having a keto group at carbon atom number 2, whatever you are seeing in the board is not 5 carbon, it's not a pentose. It is a 5-sided ring. The word ring has to be there. So fructose and the pentoses, I mean ribose, the one which form the nucleic acids, the RNA and the DNA. The riboses and the ribuloses, the ribose will always form such a structure. Now fructose, since it has a keto group at carbon atom number 2, will result in a 5-membered ring, which is different from a pentose. That is a furanose. Pentose is a 5-carbon sugar. Furanose is a 5-membered ring. So hemiacetal is named after aldehyde group, correct. Hemiketal, correct. Yes, aldoses form pyranoses, while ketoses and pentoses form furanoses. Very correct. Bernard? 101% correct. Shall we proceed? I also mentioned that we should draw the structures of, I'm referring to my questions, please. Structures of beta galactosamine, D-glucosamine, alpha D-manosamine. I just wanted us to have a jog around on the amines of the sugars. Imagine, amines of the sugars. Because you saw the heteropolysaccharide, they have the components of those amines of sugars in them. So I told you this time round is the one I've introduced the amines of sugars. I always don't introduce them, but I saw how important they are. If you have glucosamine, do you know the glucose which we have? The glucose, D for that matter. 1, 2, 3, 4, 5, 6. Glucosamine. The student who asked about how to put something to the left and to the right, if you are drawing D, just go straight at carbon atom number 3, put your OH to the left. It will direct you on what to do with the other carbons from number 2 to number 5. That is glucose. But now you are talking about glucosamine. Go to carbon atom number 2. Imagine, I told you the secret of drawing these structures is balancing the bonds. You can see nitrogen there. And you know very well, nitrogen atomic number 7. You need to have to balance around the nitrogen, 3 of them, 3 bonds around it, such that this one, if you write it in long form, it will be something like this. So we don't want long form. We already know we need to balance, so put NH2. That is D, glucosamine. We are going to draw galactosamine. 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 1, 2, 3, 4, 5, 6. We said D-galactose for that matter. 1, 2, 3. 3 and 4. Put to the left. I'm still trying also to cover what the other student was saying, how he can tell what to put to the left or to the right. Just put the amine group, imagine. That is galactosamine. Remember we talked about galactosamine being the component of some of the antigens. So it's just galactose itself, but then the amine group is there. Manosamine, manosamine looks different. Manosamine, still on the same. Manosamine, still on the same. One, 2, 3, 4, 5, 6. Manosamine. 1, 2, 3, 4, 5, 6. Now, manosamine at carbon atom number 2, where it was much more like an epimer, we have the NH2, and then carbon atom number 3, and then 4, and 5. That is manosamine. Then lastly, we have N-acetyl glucosamine, because it's also a component on one of the heteropolysaccharides. To be precise, did I see it in heparin? Yeah. So we are going to draw glucose. It's a bit lengthy at the point where we are drawing. I'll write their names if it can confuse you. Sorry, let me first draw 6 carbons. I don't know whether the students can see or it's becoming a bit faintish. Let me come back to this, my marker pen. 1, 2, 3, 4, 5, 6. At this point where you could see, that is what I want. So we are going to draw N-acetyl glucosamine. We already had the NH here. Now it's not going to be NH2 because it's proceeding yet. You know, acetate and a methyl, that is acetate. You have the carboxyl there and a methyl. That is N-acetyl glucosamine. Glucosamine. This is manosamine. Manosamine. This is galactosamine. Galactosamine. And this is glucosamine. So it means I can draw the cyclic forms of those. I talked about alpha, D, and even N-acetyl galactosamine. You see the way galactosamine was. Just take this and put it here. You'll have N-acetyl galactosamine because it's just the same as glucosamine. Whatever was on the amine there, as long as you retain the OH at carbon atom number 3 and number 4, and then the N-acetyl amine will come on the second carbon atom, the way it shows. So I'm going to draw this one in cyclic form. So I tell you to do an alpha D-galactosamine. Alpha OH is below. Oh, the guy who mentioned about which number of carbon. This is carbon atom number 1, which determines alpha or beta. Carbon atom number 2. Number 3 is this one. Number 4. Number 5 will sit here. And then number 6. This will be number 6. So I'm drawing alpha D galactosamine alpha. So you know the amine group was this side. So the NH2 will be down here. Hydrogen will be here. Carbon atom number 3, OH inside, outside. Carbon atom number 4, same direction as the amine. You'll have the hydrogen there. And here we will have the CH2OH. Fructose is a furanose, not a pentose, correct? Oh, you are answering to Odero. Thank you, Emmanuel. Now you can see from the linear, we can easily twist our simple sugars in a cyclic form. I'm going to draw. Which one should I draw? Tell me there in the chart. In cyclic form, the ones which are up there, because we can answer the N-acetyl glucosamine. I've drawn an N-acetyl galactosamine. Is just the same structure of galactosamine, but now you put the C double bond O CH3. That will be N-acetyl galactosamine. I've done beta what? Beta galactosamine. So what we have to know here is the resulting 6-membered ring for the aldoses or pyranose. The resulting 5-membered ring for fructose and the pentoses is a 5-membered ring. But I hope it will be an eye-opener for us when you are revising. You'll be able to know now what you are reading about. Point number 3 says, we draw structures of sucrose, we draw structures of lactose, and we draw structures of maltose. Now, the Felix question come in. Felix said, what were we trying to do? What was the English? Felix, you can remind me of the English? Because I'm also going to draw one which will look even more easier of drawing sucrose, whichever way. Whichever you will think is easier for drawing lactose, the one in the notes or the one which I'm going to draw, but it's still okay, as long as you know the monosaccharide components. You have to know the monosaccharide. Repeat the N-acetyl amine, correct? So, for the N-acetyl amine, Emmanuel, I'll repeat. I already drew for glucosamine. I'm going to draw for galactosamine. We said don't get confused with everything here, just the way we draw galactose. 1, 2, 3, 4, 5, and then the 6th one. And then the first carbon will still be an aldehyde group. The normal D-galactose we always draw. So at carbon atom number 3, at carbon atom number 4, we have, that is the normal sugars. That is D-galactose, because the first one I drew, glucosamine, you know, the amines of the sugars. So at the carbon atom number 2, here will be H. Carbon atom number 2, this is, I'm drawing N-acetyl galactosamine, sorry. C, you know, the acetate. You know how the acetate is? This is just the acetate. The acetyl group is here. The amine group is here. But now you can't put an H2. If you put an H2, you do a plus. because it has to be less. It has to balance. So just put NH. They will still balance the 3 bonds, the outer shell for stability, because the configuration will be 2 to 5. So that is, sorry, N-acetyl galactosamine. You see, the galactose is still retained. Carbon atom number 3 and number 4. Emmanuel, did you get it? So it's just addition of the acetyl group, the acetates. The amine is already there. So we are just adding the C double bond O for it to balance, you know. The carbon still, it's balanced. So it's balanced, is something like that. So it has to be double bond O and a methyl group. So we are saying we want to draw the disaccharides, that is the sucrose, that is the maltose, and that is lactose. I did specify by saying that you describe much about it, but okay. Thank you. I can see we are moving together. We'll be able to revise until we get it right. So at least we can have a clue on how we draw them. So what I'm saying here is, I said we draw and you mention the type of glycosidic bond and the monosaccharide components. Very important. So if I talk about maltose, and I said, don't just throw and tell me that it is 2 glucose units. No. Tell me, these my 2 marker pens are really ugly. They have a very fat mouth, so I can't write well. So maltose, talk about alpha D glucose, beta D glucose. We are forming an alpha 1,4 glycosidic bond. Yes, we are going to draw it down there. You have lactose. Then here we'll do sucrose. The lactose, you say beta. And the first one has to be beta D, galactose. Beta D, glucose. You have to mention. And we have a beta 1,4 glycosidic bond. Sucrose, you have an alpha D glucose and you have a beta D fructose and you form an alpha 1,2 glycosidic bond. So we have to specify the monosaccharide components. You don't just throw galactose glucose. Glucose, imagine I give you a wrong. If you don't mention whether it is an alpha, because the alpha and beta are very important. If you throw glucose and galactose, will somebody think that it is in cyclic form? No. Somebody might think it could be still in linear form, which is not true. Because we said, and we are still mentioning, that they exist in cyclic form so that it can improve solubility. Sucrose, the normal table sugar, if you stir it even in cold water, it dissolves. Hot water, it dissolves very fast. Lactose, the fresh milk, will dissolve in water when preparing tea. Maltose are not good in Guinness, but the Malta Guinness is a component of maltose. So we have to talk about the cyclic form beta, alpha, very important. After this, we can see the structures. I want to draw using this, my black one, so that it can show. So we already know we have beta and alpha. We start with alpha because I told you This first, oh no, it's not even writing. This first monosaccharide component will tell much about the type of glycosidic bond. This first monosaccharide component tells much about the glycosidic bond. This first monosaccharide component tells much about the glycosidic bond. So the position of the OH in the first monosaccharide component matters much. So here, draw very well the alpha D-glucose. Now we know alpha D-glucose. So at carbon atom number 2, it will be there. 3, it will be there. 4, it will be there. It means the OH is below. Extend the glycosidic bond easily downwards. That is what it means. The hydrogen is there. So I need to give a space. The second glucose is a bit up. But still, D-glucose. Still D. Still D. And that is why maltose is a reducing sugar. If you add it to the copper sulfate, which is present in a Benedict solution, it will change to brick red. It's a bit faintish. So the naming of disaccharide bond depends on alpha or beta monosaccharides that start the bonding, correct? It will tell much. You see, it starts with alpha. Because the first monosaccharide component of maltose has the OH below the ring. It brings the alphanicity. Then 1 stands for it will attach at carbon atom number 1 of the first monosaccharide component and carbon atom number 4 of the second monosaccharide component. Can you please move camera in front? It's faintish. I think it is my pen. But if I do the permanent one, it will not. We will not rub. We will not be able to rub. Oh no, that one I don't want to interfere with. I'll do the black. I'll do the black one. I think it is faintish because my marker pen is almost. It's drying up, and even this one.
My tap.
If you tap it right, let me try to make it clear to see if the camera can show. I don't like going too much. I like when the students absorb. Did you already cover 1 hour? You'll tell me because I can stop and then I'll proceed. I'll proceed some other time. I like when the students go and digest. I'm trying to highlight. I don't know whether they'll see. Yes, it was a marker pen. Mwaura, it was a marker pen, which was becoming faintish. The camera didn't even have a problem with that. Yes. So it's my marker pen. Can you see it? Maura, is it a bit? It's a bit clear. The other side is a bit. I have to. Yeah, let me make it clear. it a bit visible? It's okay. Thank you. So, I don't like taking much time, but if you can allow, we pause and then we proceed with the remaining. You'll tell me when, because I think we should not also swallow too much until the students become tired. Felix, I'm waiting for your response. And then it needs to be supported by another person. Do you think you people we should stop and then we can proceed? We have how many days before we have our class next week? Maybe you can alert me again. Next week before Friday, we do question. We start with question 3 and we finish. We go through to question 10 because they're a bit similar. We can pause, I think, because we don't need to pump in a lot. The world is not ending today. I want the students to digest. So maybe you can go back and check if you can draw the structures on your own for question 1 and 2, whatever we've been describing. Then Felix, you let me know before we start on amino acids next Friday. Please let me know because I need to finish with question 3 to question 10, which is not much because now we've learned much about the structures, the cyclic form. So I thank you so much. Yeah, we can stop. No, not tomorrow. Eric, Eunice, tomorrow is too soon. You also need to take your family out, kidogo. And then you come. Then Madam Winnie is waiting. No pressure in life. But you'll update me before we have a class next Friday. I should finish the revision for carbohydrates. So thank you all, the ones who logged in and the ones who also disappeared, because now I also disappeared by adjusting my camera. I'm sorry about it. So I just wish you well and let's work together. It shall work. We need an effort. We need to sacrifice our time for us to make it work. And all the best and God bless and have a good night. Yes, please. Yeah, next week, maybe Wednesday, you let me know. I'll be able to improve much on even now on how we project the camera and even the marker pen. So yeah, so just inform me. You agree? If it's Wednesday next week, then we'll be able to proceed. Thank you so much. And God bless you too. You people are just wonderful. And have a good night.